Okay, so now I'm going to talk about unidirectional communication between processes, usually, or for example, between a parent and a child process. This is called a pipe. A pipe, like the name suggests, is like a pipe that communicates between one process and the other, while one process writes to the pipe, sends information, and the other process gets the pipe or reads the pipe. So let's start by demonstrating it. We have two processes, process A and process B. Now we have data. Process A writes to the pipe, and through the pipe, the data transfers to process B, which reads the pipe. So one process writes to the pipe, and the other reads from the pipe. This is the idea of the pipe. Now, when we create this pipe, we usually do it between a parent and a child processes. A good image for this is from Geeks and Geeks. You will see that there is a parent process and child processor. Here is the pipe. Now, each one of them can read and write to the pipe. You can see that FD0 reads from the pipe and FD1 writes to the pipe. The same goes in the child process. FD0 reads from the pipe and FD1 writes to the pipe. Now, in order for it to be a unidirectional communication process, so the one process closes its read. For example, parent process will close FD0, the read, and will stay with FD1, and the other process, vice versa, closes the write FD1 and stays with FD0. So one process can write while the other process can read. And if we want it in a reverse order, that this one will read and this one will write and this will read, we'll do the opposite. This will stay open, this will stay open here. So this is the idea of the pipe, to transverse information, to transverse data between two processes in a unidirectional way of communication. One reads to the end of the pipe, and the other one writes to the end of the pipe, and the other one reads from the end of the pipe, from the other end. So in relation to a code, let's see how it works in a very simple way. You will see that the pipe is created before um, we are forking the process. Take the process and copy the process such that the original copy will have another copy. The copy will be called the child, and the original process will be called the parent. This is forking. Now you see this is C code. You will see here that we have a pipe. We create this array of read and write, so it's size of 2. And this way, what we are writing is what we are reading. And here we create the pipe. And look and see that we create the pipe before we are forking, because I want to create a parent process with the pipe before I'm copying the whole process. Because if I create the pipe here before I fork, when I'm forking, the child will be created already with the other ends of the pipe. So I need to create the pipe before I'm doing the fork operation. This is why the pipe is created here before the forking. And I'm doing the forking, and as usual, the parent process is here when PID is more than 0. PID is the result of the fork, and the child is in on else, and the parent will write to the pipe, write to the end of the writing, and the child will read from the pipe, and then we end. Okay, so this is the idea of the pipe and its relation to forking, and this image really illustrated this one-way communication that we can decide which place is closed and which place is open. You can see that on the parent we close the read end, and on the child we close the write end. We could do it in the other way around, but you just wanted it this direction. Okay, and after we write, we wait for the child to terminate, and then we read in the child and close and exit. Okay, so this was about pipe on operating system. Thank you very much. If there are any mistakes or corrections, please tell me. Thank you very much, and this was by Pipe, and this is it.